Have you ever stopped to think about the world around you? Not just the buildings and the roads, but the very air you breathe, the water you drink, the ground beneath your feet. What if I told you that everything you own, everything you use, everything that powers your life originates from the earth itself? From the smartphone in your pocket to the food on your plate, it all begins with something we call a natural resource. But what are they really? How did they come to be? And why are they the silent, often invisible, foundation of our entire civilization? We are about to embark on a journey, not across continents, but deep into the very fabric of our planet. We will uncover the ancient origins of the materials that build our modern world, explore the vast and varied treasures hidden within the earth, and confront the critical importance they hold for our future. This isn't just a lesson in geology or economics. It's the story of humanity's relationship with its home. Prepare to see the world in a way you never have before, because the story of natural resources is the story of us. So, what exactly are natural resources? At its core, the definition is beautifully simple. Natural resources are materials or substances that exist in nature, independent of any human action, which we can then use for economic gain or to support life. They are the planet's raw inventory, the wealth provided by Earth's own processes over millions, and sometimes billions of years. Think of the Earth as a vast, magnificent storehouse. Inside, you'll find everything from towering forests and flowing rivers to hidden veins of gold and vast underground reservoirs of oil. Humans did not create these things. We discovered them. We learned to harness their power, shape their form, and build our societies upon their availability. These resources are the fundamental inputs for everything. The cotton in your shirt grew from the soil, nourished by water and sunlight. The plastic of your computer mouse was derived from petroleum, a fossil fuel. The glass of your window was made from sand. Understanding this concept is the first step to appreciating the intricate web of dependence we have on our natural environment. They are not just commodities. They are the lifeblood of our planet and our civilization. To truly grasp the significance of natural resources, we must travel back in time, long before humans ever walked the earth. The origin of these resources is a story of immense geological timescales, powerful cosmic events, and delicate biological processes. Let's start with the very beginning. The heavy elements, like the iron that forms the core of our planet and the gold we treasure, were not forged on Earth. They were created in the heart of dying stars, massive stellar furnaces that exploded in supernovas, scattering these precious elements across the cosmos. Billions of years ago, this cosmic dust and gas coalesced to form our solar system and, eventually, our planet. As the young Earth cooled, these elements differentiated. The heavier ones, like iron and nickel, sank to the core, while lighter materials formed the mantle and crust. This primordial sorting process is why certain minerals and metals are found in specific layers of the Earth. Then, life entered the picture. Around 3.5 billion years ago, tiny microorganisms began to perform photosynthesis, releasing oxygen into the atmosphere. This great oxidation event fundamentally changed our planet's chemistry, allowing for the formation of many of the oxide minerals we mine today. Fast forward to the Carboniferous period, about 300 to 360 million years ago. Earth was a swampy, tropical world covered in gigantic ferns and primitive trees. When these massive plants died, they fell into the swampy water, and instead of decomposing completely, they were buried under layers of sediment. Over millions of years, intense heat from the Earth's core and immense pressure from the layers above compressed and cooked this organic matter, transforming it into the coal seams we now excavate. A similar process occurred in ancient oceans with tiny marine organisms called plankton. When they died, they sank to the ocean floor and were buried under sediment. Over eons, this organic soup was transformed into the crude oil and natural gas that fuel our modern world. So, when you fill your car with gasoline, you are quite literally running it on the remains of ancient life, powered by sunlight captured hundreds of millions of years ago. Even the soil we depend on for agriculture is a product of millennia of rocks being broken down by wind and rain, mixed with decaying organic matter. The origin of natural resources is a testament to the planet's dynamic and patient history. Now that we understand their origins, how do we categorize this vast planetary wealth? Natural resources are typically classified into two main types based on their ability to be replenished, renewable and non-renewable resources. This distinction is one of the most critical concepts for understanding sustainability and our long-term survival. Renewable resources are those that can be replenished naturally over a relatively short period of time on a human timescale. Think of them as the Earth's interest, the gifts that keep on giving, provided we manage them wisely. Examples are all around us. Sunlight, which powers solar panels, is for all practical purposes infinite. Wind, which turns the blades of turbines, is generated by the sun's uneven heating of the earth. Water, which flows through our rivers and fills our lakes, is continuously circulated through the hydrologic cycle of evaporation and precipitation. Forests are another prime example. Trees can be harvested, but if we replant and manage the forests sustainably, they will grow back. Living things like fish in the ocean and wildlife are also renewable, as they can reproduce and maintain their populations if not overexploited. The key with renewable resources is the rate of use. If we cut down trees faster than they can grow, or catch fish faster than they can reproduce, we can deplete even a renewable resource, a concept known as resource depletion. On the other side of the spectrum are non-renewable resources. These are resources that exist in finite quantities and are consumed far faster than they are formed. Once they are used up, they are gone forever on any human timescale. They are the Earth's principle, a one-time inheritance that took millions of years to accumulate. The most prominent examples are fossil fuels, coal, oil, and natural gas. As we discussed, their formation process is incredibly slow, meaning the reserves we are burning through in a few centuries took over 300 million years to create. We are drawing down a bank account that will not receive another deposit for an unimaginable length of time. Minerals and metallic ores fall into this category as well. Elements like iron, copper, aluminum, and gold are present in the Earth's crust in fixed amounts. While we can recycle them, the primary ore deposits we mine are finite. Every ton of copper we extract is one less ton left in the ground. This finite nature of non-renewable resources presents humanity with one of its greatest challenges: how to transition our economies and lifestyles away from a reliance on finite materials before they become scarce or economically unviable to extract. Let's bring this down to earth with some concrete examples. Look at the world around you and you'll see a tapestry woven from both renewable and non-renewable resources. A classic renewable resource in action is a hydroelectric dam. It harnesses the kinetic energy of flowing water, a resource continuously replenished by rainfall and snowmelt, to generate electricity without consuming the water itself. A wind farm, with its towering turbines spinning in the breeze, is another perfect example. In agriculture, the soil is a renewable resource that supports the growth of crops like wheat, corn, and rice year after year, provided we maintain its fertility through sustainable farming practices. Timber, harvested from sustainably managed forests, provides the wood for our homes, furniture, and paper. These resources are part of a dynamic, living system. In contrast, the world of non-renewable resources is equally pervasive. The device you are watching this on is a museum of non-renewable resources. The screen contains indium and tin. The battery likely uses lithium and cobalt. The circuitry is made of copper, and the processor is built upon silicon, which is refined from sand. The plastic casing is a petroleum product. The electricity powering it might come from a power plant, burning coal or natural gas. The steel frame of the building you're in was made from iron ore. The concrete in the foundation was made with limestone and other minerals. The gasoline in cars, the jet fuel in airplanes, and the asphalt on our roads are all derived from crude oil. These resources have enabled the industrial and technological revolutions, allowing us to build complex societies and achieve a standard of living unimaginable to our ancestors. They are incredibly useful and energy-dense, but their defining characteristic is their fit. So, why does all of this matter? The importance of natural resources cannot be overstated. They are the bedrock of human existence and progress. Economically, they are the primary factors of production. Entire industries, from mining and drilling to agriculture and forestry, are dedicated to extracting and processing them. The wealth of nations has often been directly linked to their endowment of natural resources. They fuel our industries, build our cities, and create the products and services that drive the global economy. But without them, there would be no manufacturing, no transportation, no energy, and no modern infrastructure. But their importance extends far beyond economics. Socially and culturally, resources have shaped human history. The quest for salt, spices, gold, and oil has driven exploration, trade, conflict, and colonization for millennia. The availability of fertile land and fresh water has determined where civilizations rise and fall. Most critically, natural resources are essential for survival. We need clean air to breathe, fresh water to drink, and fertile soil to grow food. These are known as ecosystem services, the benefits that nature provides for free. Healthy forests regulate the climate and purify the air. Wetlands filter pollutants from water. Bees, a biological resource, pollinate a vast percentage of our crops. The importance of these resources lies not just in what we can extract and sell, but in the life support systems they maintain. The challenge we face today is a direct consequence of their importance. Our growing global population and increasing consumption are placing unprecedented strain on both our renewable and non-renewable resource bases. We are depleting fish stocks, degrading soil, and rapidly burning through our fossil fuel inheritance, leading to climate change and environmental degradation. The story of natural resources is now at a critical juncture. Our ability to understand their origin, manage their use, and innovate for a more sustainable future will define the prosperity and perhaps even the survival of generations to come. The Earth has provided us with an incredible inheritance. What we do with it is now up to us.